Alright, in this video I'm taking a look at the final part 6 of a 6-part question where we've worked through a recursive definition of a function and we've converted it to a closed definition, making use of geometric series. And then we used induction to prove that those two versions of the function were equivalent. Now, if you haven't already, it might be worth taking a look at the videos for parts 1 to 5. I'll provide some links for those. Here in part 6, we're told to create a spreadsheet that evaluates both the recursive and closed definitions of the given function from F0 to F15. And then we're given a kind of screenshot to guide us on how to set up that spreadsheet. So what I've got here is I've got Microsoft Excel open. That's my spreadsheet of choice. Whether you use Excel or any other version won't really matter. If I follow the layout of what was in the screenshot in the question, we'll have a column for n, we'll have a column for our recursive definition, a column for our closed definition, and then what I'll call the delta. That triangle symbol in that screenshot means delta. We want to consider from n is equal to 0 up to 15, so let's go equal to the above value plus 1. And I'll drag this down until I get to 15. Yep, so there's our 15, 0 to 15 for n. Now for our recursive function, you remember hopefully that f0 was defined as 20. And then for all following values, the recursion was equal to 4 times the prior value minus 1. And so we get f1 is 79. Hopefully that looks familiar if you've watched the prior videos. And now I can drag this formula down and it will give us the values for all the other values of n. A quick way to do that here, I can just hover over the bottom right hand corner and double click. And we see that we got our numbers, they get pretty big pretty fast. Now what we want to do is do the same calculation using our closed definition and keep an eye on the delta. So I might just create the formula for the delta, so the difference between closed and recursive. Now, what we hope is that that difference will be 0. Currently, it's obviously going to be just equal to the values because we've got nothing in closed right now. But as we fill out closed and drag it down, hopefully these all become 0. And that's essentially our kind of high-level check over and above the induction that, again, our closed and recursive versions are equivalent. I mean, the induction really gives us the comfort. This is just an extra layer of comfort, really. So our closed function was equal to 59 times 4 to the power of n plus 1, and then I need to put that all in brackets because then we divide by 3. So we get 20 for our first n is equal to 0, that's good. If I drag down one more, n is, f of 1 is 79, again good. Now if I double click this down, we get deltas of 0 all the way down. So that gives us comfort that, you know, our recursive and closed versions are equivalent. You could go down as far as you like. You'd end up getting, you know, very, very large numbers. I suspect we were told to stop at 15 because, you know, going beyond that, maybe the numbers are kind of just too big to really, you know, deal with well. Excel can handle pretty big numbers, but it does have its limits, 15 floating points. But anyway, for the purpose of this question, this is how you would go about it. This is how you would create that spreadsheet, nothing too sophisticated, but a nice example of how having a technology like spreadsheets can help complement the mathematics we do and really give us a way of seeing what we're dealing with. Sometimes it can really help to have actual numbers in front of you to solidify the algebra that you're working with. So hopefully that all makes sense, and hopefully you've been able to follow along with all the videos working through each of these parts. I think it's been an interesting question, quite a nice one to perhaps introduce you to induction if that's something you're learning for the first time. This is quite a nice question to step you through and let you see how it works with something concrete like a recursive formula. So there you have it. Hopefully that's all been helpful, and tick boom.